Hi, the 1D insert operation that is left over is insert at a given position. We have to implement in C++ using arrays. So let us first quickly discuss about the algorithm that we are going to use. The first step is, as usual, check whether the list is full, that we know, but one more condition we have to check is for insert at the given position, if the position is valid or not. When we will say a position is valid is, for example, if a list contains already 3 elements, right, there are 3 elements. When I want to insert, I will be using human indexing for referring to the position. So I can insert at the first element. For example, if I want to insert 4 as the first element, then the list should look like this: 4, 1, 7, 8, right. I can do 1 as the position, or I can do 2. If I tell 2, it should come here, and if I tell 3, it should come, and I can tell up to position 4, right. If there are 3 elements, I can tell even 4, because this will be equal to insert end, right. But I cannot tell 5 or 6 because those are invalid positions. And similarly, I cannot tell which is less than 1 because 1 is the minimum index when we are using human indexing. Next step tells that if the list is, this is a special case we write in algorithm, maybe when implementation this may not be required. Okay, so if the list is empty and the position is 1, then place the element as the first and increment the number of elements in the list and return true. Okay, and step number 3. This is when you have got some elements in the list and you want to place the new element at the given position. Then what we should do is, as we did in insert beginning operation, we have to move the elements from the end of the list one step rightwards. Okay, one step right. We have to move. We have to start from the last element and we have to come till position -1. Once again, recall why I am telling position -1 is, since we are following human indexing, we have to do up to position -1, the right moment, and then the empty space will be filled with the new element what we have got. This is the algorithm. Let us map it to the analogy and see. Actually, there are 3 people. When I want to place the element new person in the second position, then what should I do? I must move this person here as well as this person here, right. Both should be moved so that this chair becomes free and I will make the new person to sit in this chair. But look at the index that is being followed inside the system. It is 0, 1, 2 and so on. So only I was telling that you have to move the elements till position -1. That should be done. Okay, and let us look at the complexity of the algorithm. When we look at the complexity of the algorithm, it depends on the number of elements in the list. When you look at this example of people sitting in the chair, assume that it's a very big hall and there are 100 people, and if a new person is coming and he has to sit as the 90th person, then 10 people has to move like that. But so what can we tell if 110? No, it doesn't depend on the number of people alone, but also it depends on the position where the element has to be inserted, right. But when we look at it, the worst case position is position number 1. If the new person has to occupy position number 1, then the complexity is big O of n. All the elements whichever is currently in the list has to be shifted right. Okay. So this big O notation actually gives approximation only, closer approximation. So big O of n will be a very good time complexity value for this insert at a given position also, right. So now let us go into the implementation and discuss. Yeah, already we have got other functions. Now we are going to insert at a given position. Return type is bool. Okay, I have to declare it. Let me declare it and come. So return type is bool, and then insert position, and you will tell first the position. 2 things have to be passed now. One is the position, other one is the element which is going to be inserted. Okay, and let us come back to the implementation. So insert position, right? You will tell the position where the element has to be inserted and the element which is going to be inserted, right? So first thing is the boundary check we are doing, whether the list is full, you are checking, or use the or operator and you are going to check position less than 1, right? 1 is the minimum position, or position greater than number of elements plus 1, right? So it can be from 1 to number of elements plus 1. That is the boundary limit that is possible, right? So if it is greater than number of elements plus 1, in that case also this is going to be a failure thing. So let us return false, and if not, right, then we need to iterate. Let us declare a I. I am just declaring. You can declare even inside the for, but it's a good practice to declare it in the beginning. Okay, so for I equal to number of elements minus 1, that is the place where the last element is there. Okay, and you will be telling I greater than or equal to position minus 1. Please understand why I am telling position minus 1 is because the difference in the human indexing and computer indexing, right? I am going to now tell elements of I plus 1 is equal to elements of I. I am going to move the elements one step right, and then I will be telling elements of position minus 1 is equal to x, right? This is what I will tell, and I will be incrementing the number of elements, and then I will tell return 1, right? Sorry, I can tell return true here. Okay, so return true can be said. Let us compile and check whether there is any error, right? Is full is not declared, yeah, because F has to be in capital letters. Yes, compilation is done. Now let us go and see the code. Main part is already returned, and what is returned there is I am going to have a I am going to read the value of n. Let us tell the value of n as 3, and then I am doing insert beginning 3, and then I am doing insert 10 2, right, and insert beginning 1, right, it comes here, and I am trying to do insert at a position means I will get a error. Why? The list is full. So insert position will fail due to that. Since the list is full, it will fail. Now let us take the same case. I give the capacity as 4 and I try to insert. All these 3 steps will be successful and will be placing the elements as we are seeing here. But what about this? Insert position 1, 10 I am telling, right? You are trying to insert at the position 1 and 10, right? So now it will be placed here, right? This will be a successful thing, and if I try to insert again another one element, I will be getting error. This will fail, this insertion will fail. You will see the message insertion failed, and you will see the list is also printed. And next, if I increase the capacity to 5, then you will tell all the insert operations are successful. So 4 also will be placed. So you will be saying 4, 10, 1, 3, 2. This is what we will see if this is also successful, right? So let us try executing the code. Let me give the capacity as 4 and see what I have got. If I give the capacity as 4, I should get 4, 1, 3, 2. Okay. Actually, why my insert position is failing? 1 is the position, I suppose, and 10 is the element, right? So that is how we are reading it. I think that was a save problem. Now let us check what the code prints. When the size is given as 4, it has to print 10, 1, 3, 2. and also it will print insertion fail because it couldn't insert the fifth element, right? And when I give the capacity as 5, what will happen? 1 3 2, these 3 will insert 1 3 2, and then 10 will be inserted at the position 1 and again insert beginning, right? So you see that it will print as expected 4 10 1 3 2, right? It's working correctly. And we can also check, suppose if I try to insert at the position 5, there are only 3 elements. How does the code respond? We can see insert at the position failed, right? It has failed. And why it's printing 5 elements is it's because here we have just in the print list we have printed up to capacity. Let me change that to number of elements, right? So now if you try, you will see. So you see only the elements which are inside the list is getting printed. Okay. So I will share the code in the GitHub and provide the link in the description box. Please try it by yourself, and you can take this code and use it for your learning purpose. Thank you.